We had looked into the channel PCM30 uh, frame, right, where we looked into various time slots, right, where 0 was for frame synchronization and time slots 1 to 15. The 32 time slot, basically how it was diversified, right? So continuing with that discussion, right, now we will look into the PSTN, and we will explain how it's an example of circuit switched network, and also we will see three of its applications, right? So we had seen how this is an example of CS network, which is circuit switched network. So let me just revise that. The PSTN is worldwide collection of interconnected public telephone networks that was designed primarily for voice and traffic. So basically, as we all know, initially, these telecommunication networks were developed for only voice. They didn't have data in mind, right? So they thought probably, we can have a different connection for data. But then as the advancements went on, right, they got to know that, innovations through innovations, that, in the same line or in the same channel, it could be transferred, the data could be transferred. So you can have both voice and data on the same line. So a lot of research and development happened in this area, right? And they were able to come up with this solution, unique solution. PSTN is a circuit switch network that is a dedicated circuit, right? So it's also referred to as sometimes channel. So we have a dedicated circuit which actually helps in switching from one circuit, or from one network, or from one tower to another. See, for example, when you're traveling, right, there's a concept called handoff. So what is this handoff? Handoff is something where you're traveling from point A to point Z, let us say. So in between, you will have a lot of towers between your travel. So your cell phone will actually, connect to those towers. It is not that, let's say, for example, if you have purchased a SIM card in city A, right, your SIM card will not rely on networks with city A. But then, as you keep moving on, right, with the same service provider, the network also keeps shifting from one signal tower to another signal tower, right? So yeah, so the circuit helps in getting this switching done, and this is called handoff, right, where the network actually shifts, from one tower to another. So that process is called handoff. So it's established for a duration of transmission, such as telephone call. So not only, does it help in handing off, but then for establishing connections. Okay, when you make a call, this contrasts with the packet switched networks, in which messages are divided into small segments. Remember, I had told you where these information is actually broken into small pieces, and those pieces are called packets. Okay, and each packet is sent individually. The internet is based on this switching protocol. Now remember, last time I had shown you how this packets were sent, how it was received, right? 4 sent, 0 lost. So all these are in the form of packets, and it comes under the concept of TCP/IP, which is transmission control protocol. Now let us look into the applications. What can be the applications of this PSTN? Okay, so it is a wonderful technology, and how are we using it, and in what fields are we employing them? So we will just look into it, and we will have a discussion on it. Originally only an analog system, the PSTN is now almost entirely digital. So previously, as you know, we were relying on only analog type of systems, right? So one good thing about these analog systems were that you were able to track information at each point of time. But then in digital, you don't have that luxury. But then at discrete times, right? So at intermediate times, you can actually track information So unlike analog, which is continuous with respect to time. So yeah, even though most subscribers are connected via analog circuits, and it now includes mobile phones in addition to fixed line phones. So not only analog circuits, but then we have digital circuits. Not only the landline connections, but then we also have the mobile phone connections. Only the very oldest and most backward parts of PSTN is still using analog technology. So it's still there, analog, right? We cannot say that we can fully rule out analog, right? At some point of time, we do need analog. For anything other than the final mile connections to individual homes and other end users, right? See, for example, um, even if the connection is wireless, okay, let's say you have connected wirelessly to your internet, but then the connection that has come to it is wired. So what I'm trying to say here is you cannot just move away from one technology. It really takes decades and decades of time to move on from one technology to another, right? So the same is applicable with analog and digital circuits, right? So we were using analog previously, right? And right now we are with digital. So it doesn't mean that we do not need analog, but then we still need them. Okay. In recent years, digital connections have been increasingly been made available to end users through services such as ISDN, Integrated Services Digital Network. These days, with these connections, you are even able to get internet connections. You are able to even get connected to the televisions, and these days televisions, they require internet. If you just can give them internet connection, right? So that should be sufficient with the broadband connections given. Okay, fine. And you can see all the smart devices that we have these days, right? So these devices, they just need an internet connection, right? Once you give them the internet connection, it does its job. But the downside is, you're vulnerable to attacks, right? So I was just reading, an article where India ranks about 10th with respect to cyber security ranking, right? So it's not that we are not vulnerable, or any other country for that matter. So it can happen anytime, and it can actually change the way things uh, things go on as time passes by. So this is one such field where security becomes a very prime importance. Okay. Recently I was even hearing news about data being wiped off with the external hard disks. Um, so as soon as the hard disk is connected, right, so you find that the data is being erased, and by the time you notice, right, your data is already gone. So these are some kind of tricky hacks that actually keeps going on, and measures have to be taken to keep ourselves secure, and we should try not to get caught by these links, okay, unknown links that you click on. Fine. Homes and businesses can make both local and long distance telephone calls. So it's not only just about connecting from one building to another building, right? Not only from one state to another state, but then this was going beyond countries, right? So international calls. So you had to have a standard working protocol, so that once a call establishes, the technologies used in the other countries also should be the same. If not, then there's no point, right? Your call wouldn't go through. Callers can speak and be heard by another, because communication is bidirectional. I remember talking to you about simplex and duplex connections, right? So in simplex, you were only able to pass information, right? You were not able to, receive back the information. So, but then in duplex, things changed. You were able to send as well as receive information. So two-way communication happened. So, so these days, as you know, our communication is all two-way, right? We don't have one-way communication. We used to have technologies such as pagers, right? So pages was one such technology where if you had to send message to a person A, then you had to call to the pager company, and then you had to send the message, and the message would actually come in the form of text with a small display. I don't know how many of you are aware of that. Have you all seen a pager, or probably are you all aware with pager technologies, students? Have you all heard about it? Yes, no?
Yes, I've seen it in movies.
Yeah. So you can you can see that, or you can analyze that, if in case the person owning the pager, he has to get back to the person who has sent the information, not possible, right? Because it's just a one-way connection. So that technology didn't actually work through. Uh, of course, it helped the marketing companies, where they could just push information to the customers, or probably business people. But then that was not working out quite right, and things changed. Once cell phones came into existence, and all are caught up in the world of technology with the help of cell phone, right? So subscribers can receive service from their local uh, telecommunications company. The other thing, the other way that I would like to explain is subscribers can be connected by end-to-end telephone numbers, right? Just like how we do right now. And the existing connections are primarily used to transmit speech. So only speech was possible with Pstn, not data. Okay. After hanging up, the connection is closed, and the resources used become available to other subscribers. It is just like what we are using right now, the time based, right? So if you're occupying the channel for some time, then after a certain threshold limit, then that would be disconnected, and it will be allocated to someone else, and the channel which was allocated to someone else will be allocated back to you when you try to establish a call, right? So this is how things work out with uh, having uh, the connections done from one user to another, right? Now there's an interesting concept called Erlang, okay, ERLANG. So this is a unit, just like how we have kilos, right? How we have seconds, okay? How we have hertz. So similarly, Erlang is a unit, okay, which actually deals with the traffic intensity. How many calls came? How many calls dropped? Okay, and what is the capacity of the network? How good is the network? Is the network able to sustain these many calls? Right. So all these calculations and analysis will be done based on these observations, right? So it's possible only when you manually work out with this information, and then start deploying the network. So say for example, there are about 100 connections in a particular area, right? And if your network doesn't even support about 10 people, so there's no point in investing and building an infrastructure for communications, right? So instead, what is done is manual calculations are done, and then we try to see if it's feasible. If it's not feasible, then we work out with bringing up a better connectivity. So this is how this Erlang plays a very important role, right? Where we get to know the performance, basically performance of the network, right? Okay, so it's a dimensionless unit. Okay, keep that also in mind. 1 hour unit of continuous or intermittent telephone traffic, conversations, faxing, or internet connection. So faxing also is one sort of very good technology where you can actually send information, right? It will just be like scanning an information here, and that gets printed at the other side. So it will not be in the form of voice, or but then it will be in the form of a printout. Okay, so it's just like you are sending a printout somewhere else, but then instantaneously. Okay, so that's fax. And then internet connection, unlung being equal to 3600 call seconds. Okay, so this can also be called as 36 CCS. A single 1 hour call to 30 minutes call, or it can be a 15-minute call. So how do we get this 36? It is 60 into 60. Okay, so 60 minutes and 60 seconds, right? So 1 minute and 60 seconds and 60 minutes. So 60 into 60. So that gives me the number 3600. So it is calculating for 1 hour. So 1 hour is taken as a constant, and then you can replicate it, or probably you can use it as a multiplying factor for the 24-hour format. Okay. Named after the inventor, Danish telephone company engineer, okay, Poiner, Agner, Kornop, Erlang. Okay, so that's the name of the engineer who actually came up with these, kind of technology, where we were able to check the performance of the network. Okay, now we have the symbol. Okay, Erlang has a symbol E. Okay, and it's a dimensionless unit. Okay, why do I say dimension? Because the numerator and the denominator will have the same thing, so it becomes dimensionless. Okay, so it is a measure offered measure of offered load or carried load on service providing elements such as telephone circuits or telephone switching equipment. So this becomes very important in understanding how the network actually works. So how much of load, okay, what can be done if the load is more, and when I say load is more, users are more, the usage is high, how do I increase the capacity? So all this will be taken into consideration. A single cord circuit has the capacity to be used for 60 minutes in 1 hour. So we are having a calculations based on this 60-hour duration. So full utilization of that capacity, which is 60 minutes of traffic, constitutes 1 Erlang. So if I'm using the traffic for 1 hour, okay, that is 60 minutes, then I can say that it's 1 Erlang. Okay, so basically Erlang is talking about the capacity of the network, the load carrying capacity, and it will help us understand the performance. Now, why is this needed? Why is it so important? Is it really necessary to have this kind of facility? Yes, can I have some answers? Yes, it is very much necessary. Good. Because we can value the performance, and we can actually check how good the network is. Now we will solve some problems, right, with reference to traffic intensity, and we will see what kind of formula is used, and we will also see, how to solve a problem based on the formula, right? So this is the formula for calculating the traffic intensity, which is A is equal to C into T divided by T. Now you can see that A is nothing but the traffic intensity, right? And you can see that the intensity is in Erlangs, and then C is the number of calls, okay, and T is the average duration, and the capital T is the period of measurement, okay. So most of the time, we get confused with small t and capital T, right, where T is actually the total period, okay, total period. uh, and the small t is nothing but the average duration of the call. So if you have multiple calls, right, you have to just take it, and you have to average it, add it, and divide by number of calls. So that's how basically you take an average. So let's solve an example here, right, and we'll be able to understand how this formula works. So the problem statement is, in a local switch, the number of calls in an hour is about 1800. So in 1 hour, we are getting about 1800 calls. Okay. And the holding time of a call is about 3 minutes. Okay. So the hold time is about 3 minutes. So we have to calculate the traffic intensity of that. Okay. So just look at the formula and how we have substituted. It's a simple one, right? So A is equal to C into T by T. So C is, the number of calls. So I bring this 1800 down. Okay. And you can find T here. T is nothing but the hold time. Okay. So that 3, I'll be bringing it down here, and divided by duration is going to be 60, because it says for an hour. Okay, it says for an hour. So once I have this formula here, right, you can just substitute, okay, and we'll be getting about 90. So it's like, performance, how much is the whole time, how many calls it was able to sustain. Now, there's a deep understanding to this traffic intensity, right? You can also check with how much calls were lost, how many calls were actually established. So all this, analysis is done in order to boost the, network's performance. So do you think it's important to boost the network's performance? Yes, no?
Yes, sir.
Yeah. Why is it important?
We get a more faster response.
Good. And then? Anybody else to add? Okay. So if we have a bad network, do you think we will really subscribe to that network? I don't think so, right? We need something which is reliable. Even though you're in some remote places, right? Still you should be able to connect, and probably you should have a good, data transfer as well, right? When I say data transfer, good speeds of internet. So based on all these calculations, right, it will help us understand how much of traffic intensity is the network handling. Okay, and based on the feedback, right, we will be able to check out and will be able to manipulate the way the network operates. Okay, explain the basic operation of the following technologies. Now, ASDN, okay, and ISDN. Why I have brought this up here is, these two are, very important concepts, right, which are actually the base of what we are having these days, right? The internet and all the stuff. So it all started off with, the ISDN network and is a ADSL type of network. So let us see with these two how it actually began and what was the process involved in them. Fine. So ISDN or Integrated Services Digital Network. So the word itself says integrated, right? So which means you are able to use a lot of services along with, the usual calls and establishing connections and all the stuff. So it's an international standard, as I mentioned, right? You just cannot have a local type of technology. If that is so, then you will not be able to connect to the outside world, right? So when I say outside world, outside your territory, you wouldn't be able to. But then, if you use these standard technologies, it becomes easy for the other networks also to comply with. Okay, just take the example of an USB, right? An USB port. If each service provider, or if each manufacturer manufactures drives in their own way, then do you think we'll be able to use a pen drive? I don't think so, right? So no. So these USB ports are to be made precisely of the same measurement. Okay, then only you'll be able to. Let's also take the example of this RJ45 pins, right? The internet cable that goes into your laptop or probably into your modem, right? So even there, that probably HDMI port, probably your VGA port, right? You just cannot have even a millimeter change of dimension, right? Everything should be in sync, should have a standard. Okay, so it is for end-to-end digital transmission for two things, right? Voice, data, and signal, right? It can operate over copper-based systems. Now, what are these copper-based systems? Not optics, right? Previously, we had discussed about optics, where transmission happens with the help of light. But here, we are using copper. So this was used previously, right? And these days, we have migrated from copper to optics. So the reason why we have done that is because this is a better technology, and also we are saving the nature by mining copper, right? And also this becomes a cumbersome process, right? Mining and getting the metal purified with all the techniques, right? All the chemical process, and it's pretty time consuming. But then these days we have this fiber cables, right? So these can be established or created in a much faster way. And of course, the data transfer, that is the interesting part. Like you can hit speeds, in gigabits. Okay, gone are the days where connections used to be in kilobits and megabits, right? So these days it's all about Gbps. How much Gbps? You can just probably look at your home connection, for example, right? So you wouldn't find that your home connection, your home internet connection is in kilobits, right? It's all in mbs, probably greater than 100 mb, or 200 or 300 mb, right? And sometimes we even get connections with gbps, right, with in the range of gigabits per second. So basically, if you have to download a large file, say 3 to 4 GB, right? So that should, technically take about 3 to 4 seconds, right? So that's the amount of speed, and that's the amount of response time and the delay, right? Okay. Copper-based systems, and this allows the transmission of digital data over telecommunication networks. So copper cables, digital network, voice and data, all these were employed. Typically, ordinary copper-based systems and providing higher data speeds and better quality than analog transmission. So, if we compare the analog transmission, it was not possible to achieve these, these technologies, these level of speeds, right? So that's the specialty of having migrated to digital technology. The ISDN specification provides a set of protocols that enable the setup, maintenance, and completion of calls. So you need to have a certain rule, like how you start making a call, how you maintain the network, and how do you complete the call, right? Remember, I was telling you in the previous session about the disconnection charges, right? The call maintenance charges, the network, on which the call is initiated, right, has to pay the other network on which the call, is destined to. So that's how, some rules are made so that, there is a unique, unique following throughout the network operators. So this is how, ISDN came up, and we will see few more points about it, and we will try to have a discussion on it. So these are, some of the advantages for analog systems. So if a question is asked, how do you say that ISDN was a better choice than the analog systems? Okay, so this can be your answers. I have put them up in bullet form, right? So we'll just go through it. So ISDN network provides a number of significant advantages over analog systems. So in its basic form, it enables two simultaneous telephone calls to be made over the same line simultaneously. So this is interesting, right? So it can make two telephone calls at the same time over the same line. Okay, so it had faster connection, and typically takes a second to make connections rather than much longer delays. So, with these analog systems previously, for a call to be established, it used to be a little challenging, right? Subscribers had to wait for a long time for their call to be connected, but this was not the case when migration happened to the digital networks, wherein they were able to instantaneously connect, right? And obviously, people were happy because they were able to establish calls faster, and they were able to get things done fast. See, if you can imagine, how long it takes for a call to be connected in the field of business, right? So it really matters. Right? So when they have to reach out for people, and when they have to make few calls, some emergency calls, and then it takes time for these calls to get connected. It's a little annoying. Not only annoying, but then it's not the best form of communication, right? So when I say that the best form of communication, it means that there could be some emergency, but then due to this delayed response, right, there can be some fatal errors. Right? Fatal errors are huge errors, right? If we take, for example, the field of aviation, right? In the field of aviation, if there's a delay, okay, between the pilot and the co-pilot, okay, just imagine what can be the catastrophic disaster that can happen, right? So communications are to be instantaneous, right? So instantaneously you should be able to connect and communicate. So this establishing of call became faster when we actually moved on to a digital space, right? Data can be sent more reliably and faster than with analog systems. So calls establishing was fast, data speeds were fast, and simultaneously you were able to establish two calls at the same time. Noise, distortion, echoes, crosstalk could be virtually eliminated. So it's not that you have to go to the, connection lines and to the switches and to the hubs and make changes. You could probably do that, virtually, with the help of software. And the digital stream can carry any form of data from voice to faxes and internet web pages to data files. This gives the name integrated service. So as I was mentioning you before, it's not only about the call, right? It's about the data, it's about the fax being sent, okay? It's about how it handles, the web pages. So all these played a very important role, and making it different from the analog network. So ISDN became a star, right? And after which, we will also learn about the ADSL. Okay, so ADSL also is a pretty good network, right? Where it was concentrating on the speeds of upload and download, right? Symmetric and asymmetric. So basically, if you have the same upload speed and download speed, we call it symmetric lines, and asymmetric lines are, basically where the download speeds and the upload speeds are not the same. Okay? Some networks will need upload, some applications would need upload speeds to be higher, and some applications would need download to be higher if you do not upload much. So there was a kind of flexibility that came in, once this technology came up. So data compression technology that allows very fast internet and connections over the common telephone lines. So these common lines were like, the twisted pair lines, right? Unshielded twisted pair lines. And using a special modem, the ADSL, okay, supports receiving download streams from 1.5 to 9 Mbps. So this was huge speed, right? When we were talking, or when we were in the era of kbps, right, kilobytes. But then this is going up to 9 MB, which is actually spectacular, right? And sending upstream data in the speeds of 16 kb to 640 kb per second. So the download was given more importance here, right? Download, because usually 90% you see, people are associated with downloading information. See, when you open a website, it's not that you are just looking into the website, but then the information is downloaded from the server. So you are at the downloading site, right? This arrangement suits a typical internet session in which more data is received than sent. So more data is downloaded than upload. So upload is just only a request that goes, say, google.com. That's a request. And the thing that comes up, is downloading information from the server. So ADSL works by allocating majority of the available telephone line frequencies for communication of downstream traffic. Okay, so it allocates different frequencies, and it handles traffic. So ADSL possesses all characteristics, okay, that we saw in this DSL, okay, digital subscriber line, including high-speed service, always on, combination of voice and data. See, previously, when we had this landline connections used for internet, as I was mentioning, if you're connected to the internet, then you cannot use voice. If you're using the voice, you cannot use the internet. So things started changing, things started getting updated, where you were able to use both voice and data at the same time, and always on connection. What is this always on? As soon as you probably open up the browser, you'll be able to browse. It's not that you need to dial a particular number and then do some steps and then you get connected to the internet. It's pretty like how we have these days. You just plug in the cable, you're good to go, right? If your settings are fine. Settings, when I say, it's your IP addresses and the gateways. So combination of voice and data support, okay, and availability and performance that is limited by physical distance. So performance was good even though the distance was far. For ADSL to work, only a microfilter and ADSL modem need to be installed. So installation was very easy. Okay, so it's not that it took 2-3 days, but then it just took few hours, okay, including setting up the connection. So you just need to have a modem, okay, and a filter. So these days, you just need a modem, that's it, right? And you call the internet company, and then they come and connect, and that's connected to your Wi-Fi modem, and that's it. All of you are hooked up on the internet. So things were changing from then on, right? From ADSL, from ISDN, where we moved on from kbps to mbps, which was a great achievement, right? So I hope students, all of you have understood the concepts that we have seen today, right? We have seen about Pstn, we have learned about traffic intensity, and we have learned about the concept called Erlang, ISDN, ADSL, right? So we'll try catching up in the next session, and we'll try and see, or probably learn about these network performance, right? Grade of service, traffic lost, traffic offered, right? So how these networks are measured and how to increase and make, or extract data from this information and ultimately make your networks better.